Okay, let's think about the case when the market demand curve is linear demand curve. So here, P equal the price per unit, and Q is the quantity demanded, and A and B, those are parameters or coefficients that are fixed at constant level. So you can imagine A and B are numbers are given. Then for linear demand curve, if I say conclusion first, marginal revenue, you can find the marginal revenue really easily for linear demand curve. So this P equal A minus BQ, that's correctly saying inverse demand curve, as you have price on the left hand side and quantity demanded on the right hand side. So when you are given with inverse demand function for linear demand curve, marginal revenue always look as same vertical intercept of demand curve, and everything stay the same. B multiply Q stay the same, but the slope of inverse demand curve is twice as steep as the original demand curve. So you only multiply 2 in front of the slope of the demand curve, then voila, you can derive marginal revenue curve very fast. Of course, you can go through all the derivative steps as you see from the slide. So we know marginal revenue by definition is change in total revenue when you increase the quantity demanded and you can sell. Then total revenue for linear demand curve, which is again price multiplied quantity. So when you multiply price A minus BQ with Q, you have AQ minus BQ square. So you can plug that information here. AQ minus BQ square, again divided by delta Q. So on the top of this fraction, you have change in quantity Q here and Q here, and A is constant. So when you change quantity, the multiply constant doesn't change, but of course you're changing Q. And again, B multiply constant doesn't change, but you are changing quantity in quadratic term. So if you learn or remember the very basic calculus, a Q square, the derivative of it becomes 2Q as you move the power 2 to the front and multiply that constant and subtract 1 from the power 2. That's why we have 2Q multiply in this fraction. So as you have this here, of course you change delta Q in the second term on the top of the fraction. As you have this fraction, now you can see that the first term has delta Q and delta Q, so you can cancel out and have A. But then on the second term, if you see, it has minus sign and B and 2Q and delta Q again canceled out. So that's how you end up finding marginal revenue becomes A minus 2BQ for linear demand function whose inverse demand function is written as P equal A minus BQ. So for example, if your inverse demand function looks like this one, P equal 10 minus 2Q, then you can immediately conclude marginal revenue for this one will be 10 minus 2 multiplied 2Q, which is 10 minus 4Q.